Guys, I want to talk about your next assignment. This is going to be the third assignment, okay? And the deadline for that is going to be next week from Friday. All right, now this is going to be about the regression that you will need to run. Each of you basically get a sample. Something went wrong during the lecture, just to basically remind you that I don't know what it was, to be honest. Okay, I mean, I was recording it, but the file was corrupted. It said literally, so I don't know what this means. But anyway, so the recording did not work, and I decided to shoot it here. And that's why I basically do the presentation again. And in addition to that, it was ambiguous. So it was not clear, as I recognize, and some of you guys have basically told me that. So yeah, I just wanted to talk about that first and give you an idea what this is going to be. But actually, you would need to run a regression. And it goes like this. So the background is as follows. So we have a so-called stochastic process, and that is going to be a first-order autoregressive process this time. Now, a first-order autoregressive process is actually a linear process where a current observation, so let's say at time point t is a current observation, would linearly depend on the past observation, which is basically the observation at time point t minus 1 in this case. And we would not go further. So the time lag basically is going to be equal to 1. That's why it's called the first order autoregressive process again. So current observations are predicted, this is how you would say, with using past observations, that we have a linear transformation of the past observation. Now there's also the noise. So the noise basically creates some sort of disturbance with respect to that relationship, and the structure here of that process, as we're going to discuss in the lecture, or we discussed it actually today, is the so-called first order autoregressive model. It has actually 3 parameters. I mean, of course, you have the slope coefficient, you have the intercept, and of course the variance of the noise, which would also be needed to estimate it here. Okay, so let me explain. So first off, again, so yt is basically the observation of the process at time point t. And then you have yt minus 1, which denotes the observation of the process at time point t minus 1. As I mentioned before, current observations, let's say, so if basically time point t is the current observation, that the observation at time point t minus 1 would be somewhere in the past. So let's say we have daily observations, right? Then the observation of the day would be described linearly from or using the observation of yesterday. This is basically how it would be, and the observation yesterday by the observation of the day before. That's why it's called autoregressive. Okay, auto means with itself. I talked about that basically during the lecture as well. Anyways, so we also have that the time frame consists of basically, or you have a sample, and most of the time you have a capital T observations. So time is basically counted from 1 to capital T, and then furthermore we have the parameters which need to be estimated. Now in addition, we're also going to assume that the noise is IID with mean 0 and variance sigma squared. Let me remind you that in a previous assignment, this was not the starting point. The starting point was about conditional variance and conditional expectation of the noise. So that was a starting point, and based on these assumptions that are part of the previous assignment, you would need to show things like, you know, what's the unconditional expectation and the unconditional variance and so on, or the conditional variance of the response given the predictor, stuff like that. So anything else would follow. So that's actually not the starting point, because it's a relatively strong assumption that the unconditional mean is 0 and that the unconditional variance is going to be a constant. In addition, it's IID. Okay, but again, so that's where basically would need to do that. That is a relatively strong assumption. We would basically require weaker assumptions, and that has lots of implications. And this was basically what the second assignment was about. And then you would have the third assignment here right now based on that, literally. All right, but so keep in mind, this is not regularly the starting point. This would be an implication. I put it basically to be IID in addition, so that makes things a little bit easier regarding estimation, so that, you know, enables basically estimation procedure as well. But again, this is not the starting point in most of the time. Now, when it comes to basically to the regression, you need to understand that there is a predictor and there is going to be a response. The parameters actually, the slope as well as the intercept. So this A is the slope and B is the intercept. And in addition, of course, the variance of the noise. So that is also a parameter. Would need to be estimated. Now, of course, the variance of the noise is not estimated by OLS, but the parameters V and A are. So this is basically restricting on that, but also the parameter sigma squared would be also estimated. Now you need to understand, if there is a simple linear regression, which it is, then there is a predictor and there is a response. Now the response will be basically the observation at time point t, and the predictor in this case would be the observation at time point t minus 1. So that basically confuses you, because I said that that's the predictor at time point t minus 1, which, you know, it's kind of ambiguous. I mean, it's not that wrong, but basically I was changing that. So thank God I basically, you know, I wasn't able to shoot the video because it was wrong. But anyway, now I think it should be clear by now. Again, so we denote yt minus 1 as the predictor, and that is, on the other hand, the observation of the process at time point t minus 1. Now, in addition, of course, these are the estimates of the parameters, and then we would also have the residuals included here into that linear structure. All right, now your task is going to be as follows. So you would need to estimate the parameters as well as basically the standard error of the regression. Now this is not the standard error of regression. This is the standard deviation of the noise, guys, but the standard error of the regression would be basically the corresponding estimation for that, you know. So anyways, I don't want to tell everything about your solutions regarding the assignment, but you would need to estimate those things for your given sample. So I will basically provide you with a given sample. The file link is going to be here. Okay, so if you click on that, I don't do it now, but if you click on it, so you look at the presentation, you'll find the file there. This is the file. So you can basically download it and you'll find basically your own sample. And in addition, you would need to answer some questions as well. So if you open this file, you'll find, I mean, this is what the structure of the file would be. This was actually, I basically had 8 twice, so I changed that to, I don't know why. So it was 8, 9, 10, 11, but everything would be the same. This is how basically your file would look like. So you have your names listed. Okay, so let's say if you find your name here, then you automatically have the sample, which is to its right. Okay, so Y1 would be the first observation, Y2 would be the second, basically, and Y11 would be the last. Now keep in mind, guys, these are basically denoting points of time. Okay, so 11 basically is the furthest point. So Y1 is not necessarily the first observation, let's say, but that would be the observation at time point 1. All right, so the Y2 would be basically the observation at time point 2. Y3 would be the observation at time point 3, and so on. So this is basically how it would continue. So you find your numbers there again. So this is just basically a representation, and this is the sample that you're going to see, and you're going to need to start from there. Now, the questions that are involved, you need to answer. The first question is basically, how many observations do you have regarding the time series and regarding the sample of the response? Keep in mind, I want you basically to be very, very careful regarding this, because this is not straightforward at the beginning. You find that basically when you put together basically the observation pairs, and that's what you would need to do, it's not going to be that straightforward, you know. So yeah, I want you to think about that. Okay, so that consists of basically a huge part, because everything else is going to be easy. So as soon as you got the sample of your predictors, and as soon as you got your sample of the response, right, at the specific points of time, so keep in mind which observation predicts which one, you know, and yeah, so that's basically what we need to think of. As soon as you got those, you would have basically the process, and everything else would be basically established easily. All right, so that's something that you would need to have, and this counts basically for 10% of the total result. Now, you need to provide those samples that you use basically for regression, and the reason for that is basically if you have the wrong samples that you set together, then I could take at least those that you have, and then put the you know, the estimation procedure around those. So I will take, if you miss your samples, then I will basically take those that you gave me, and then I would just, you know, do your assignment based on your samples that you were choosing. Okay, maybe wrongly chosen again, so you would need to basically put that together yourself. Now, please be very careful, as I mentioned before. All right, now you need to provide this basically all sample observations for each, for your response and the predictor. So 30% of your assignment is basically just, you know, thinking about what the sample of the predictor and what the sample of the response would be. Okay, keep in mind yt is going to be the observation at time point t, and yt minus 1 that you would find basically for the predictor is going to be the observation of the process at time point t minus 1. Anyway, so that's basically that. Now, number 4 is going to be the arithmetic means, and number 5, the empirical variances of each. Yeah, so that's easy. As soon as you got that, that's going to be easy. So yeah, but I want you to think about that. So the first 30% will basically be, now, what is the empirical covariance and the correlation? Okay, that's also what I wanted to have. I want you to calculate your regression coefficients, which is easy. You know, I gave you the formulas, so you see basically what the formulas were. And of course, a coefficient determination, and you would need to interpret that. So again, you will find basically what I will check what it is. That's going to be 5. So 5% basically going to be the coefficient determination. You do not need the decomposition of the variance, guys, for that. All right, so keep that in mind. That's not what you need to do. All right. Now, number 9, you need to provide a value for the unbiased estimate, let's say, for the standard deviation of the noise. And we talk about biasness regarding variance estimation a little bit. So this is also part of statistics. Yeah, and yeah, I want you to figure out which that would be. And number 10. And then you would need to assume that, if you do, this is going to be about hypothesis testing. So you would need to do a t-test here. Assume that the noise basically is normal. Then the question would be, is the slope, right? So you know what basically the slope is. This is the, I call that the slope, but yeah. So it would be basically the slope of the regression line, right? But you could also ask the question, is the predictor significant at the 5% level? I want you to test this. Okay, so just make sure that you put the things together that you basically need. All right, that's it. Okay, so that is basically what your assignment is going to be about. And the deadline is, as usual, Friday, the week after. So you have basically, yeah, you have actually 8 days to complete that. All right, guys, that was it. If you have questions, I will take those questions and answer them in the next session. So, yeah. I hope it clarified the point, and I'm going to also shoot the lecture that I missed basically with the recording, because again, so the file was corrupted, damaged or something. I don't know what happened. Anyway, so you're going to get a substitute for that as well. All right, guys. Thank you very much. Take care. Bye.